because it's algebraic and it beats out trig, and I'm comfortable you could do that. What would you launch into for number 11? What do you think, Harvey?
The A over B part, what's that called again?
Yes, what's it called? Partial fraction decomposition. Not because we just did it, because of the denominator being a product of non-repeating what? Linear factors. Thank you, my dear. Exactly. And I'm going to have you guys go do number 8, number 10, and number 21. I'll individually assist with 8 and 10 if you can't get the right answer, because I think most of you are going to, so I don't want to make you sit through those. Number 21 we might need to discuss. I purposely left it. I think you'll be great. If you did your homework, 8 and 10 are a lot easier. So those of you at home, I started the recording a little late. We're talking about the multiple choice AP questions sheet that has 5 of them on it. I just asked them about number 9, and somebody said that was a by parts. I said, why? They said because of the incompatible functions, and we agreed we'd know how to do it because that's kind of an easy one. And then in number 11, I asked how you would do it. They said partial fraction decomposition. Again, the question was why, and I said because there's non-repeating linear factors in the denominator. We aren't going to take up time doing 9 and 11. They're working right now on 8, 10, and 21. We won't go over 8 and 10. I'll help individuals during the work time who can't get those to work out. The only one we're going to go through together is number 21. So if you're at home, make sure you would know how to approach 9 and 11, but you're trying to get the correct answer for 8 and 10. If you can't, you should be able to work it to get the starred one, and then we'll do 21 together. Oh, thank you for delivering it. Cook off pieces. We are working on 8 and 10. Get 8 to go, boy?
Yeah.
You're so smart. Put your Harvey over here. What? Gamble for? I kind of knew you would. We practiced way harder ones. You get both of those to go. Why? Make some good wits. Let the first 2 go. Thomas, we're just trying 9. 11. No, I lied. 8 and 10. We talked through 9 and 11. 8 and 10. How are you doing, Dave? Yeah, I knew you guys would get those, so I'm a little worried about 21. Because it's goofy. Your what hurts? If you're at home, you should be trying 8 and 10. And I'm a little worried about 21. But we'll see. You got it. Did you guess?
No.
You did too. Did you guess?
No.
22. This one, remember there's only two ways it can go, right? So this right in here is your integral UVB equaling UV minus VU. So one of these is the U and one of them is the VB. You don't know what f of x is, you just sort of need to try one. Does that make sense? Or maybe you can think it through almost to think of a sign edge. How are we doing, Thomas? Working through. Got it, almost. Think of a sign edge. Because of the subtraction in the UV minus VDU. So how did you know to let that guy be the UV? So you're kind of going across like that, and you're like, well, it's got to be good. That's a good way to do it. All right, most of you have your pencils down. So if I didn't give you enough time, like I said, at the end, I don't want to use your work time to go through those two, but I will at the end. If you couldn't get those to work, let me know. I'm going to go to 21. Those of you who got there, which is most of you, these were the two answers I was seeing by those who got. One of them's right. One of them's the correct process with a what? Sign error. So you're just going to be really careful with it. So I just went over to Bodie and I said, well, how did you know? So first of all, he recognized this as being, and this is how AP likes to test it, where you don't quite know who the functions are, but they're testing that you know the process, right? So on that one up there, oh, I hate this thing. I have to put my shield on. So on that one right there, when I said, well, how did you know? And then somebody over there asked me, I think it was you, Mason, right? I said, well, there's really only two options, because remember the model for it, the integral of u dv is equal to uv minus v du. So there's really only one option. Either u is f of x or u is sine x, right? So if one doesn't work for you, Kitty, try the other, right? So Bodenheimer, who'd you say the u was? F of x, which meant his dv was sine x, correct? Bodie, what's the antiderivative of sine? And that makes me feel really good about his choice, so we don't say, we have to try the other one. Because here's my uv right there, right? Minus, and what's the du going to be? Go ahead, Bodie, you might keep talking. F prime, yep. So when I use my biparts model and I go uv, I'll have a negative f of x cosine x. That looks really good. I'm feeling good about it. Minus, right, the integral of, and when I multiply this way, I'm going to have the double negatives. That's where the sign error came in. So those of you with this one, I think you had a sign error right there. Am I right? Yep. So the negative x cubes, you knew exactly what you were doing. You just made a little bit of a sign error. So then I would have f prime of x cosine x dx. How's that looking? It looks great, right, Catherine? I think you had it right, maybe with a sign error. But what that means is, lost it. What that means is, sorry, the f prime of x right here had to be 3x squared, right? So if f prime of x equals 3x squared, how do I get f? Go ahead, wrap it up. Yeah, if the derivative is 3x squared, then you have to integrate to go backwards. So it must have been x cubed, right? So x cubed was the right answer. I think most of you had that, but that one was tricky for a by parts, don't you think? Compared to the other ones. So what I want you to do in your notes, we're going to go to L'Hopital's, which we did last year. There's a proof of why it works on a slide in your weekly slide. I think it's right after today's. I'm not going to prove it. Today I'm going to sort of cruise through the front part, the order, because we talked about L'Hopital's rule before, right? It's just tomorrow, it's going to be L'Hopital's on steroids. It gets really difficult. So let's go back here. Let's go way back to AB. Are you ready? Did I give you enough time? Harvey, what do you do first when evaluating any limit? Plug it in. I'm not going to do the arithmetic. I'm going to tell you this goes to 0 over 0. Just trust me. We did it all last year, right? And so when it yields 0 out of 0, we called it an indeterminate form. But we didn't know last year that there's actually 7 indeterminate forms in math. If you were to Google indeterminate forms, you'd see 7, not just the one we dealt with last year, right? We dealt with 0 over 0 last year, but all of these are indeterminate forms. You can take this by the way off. I don't ask this anymore. It's just rote memorization, which I'm not a fan of, as you know, right, Annie Benani? Good. How's soccer going? Good. Did that hurt your head?
No.
Okay. It felt like I hit you a little hard. All right. So we can use L'Hopital's rule only for these two. So only when you get 0 out of 0 or the infinities over the infinities, and it can be plus or minus. That's the only indeterminate forms that you can use L'Hopital's rule for. However, some of these other ones, we can manipulate them to get them to result in this. So today it's basically going to be mostly what we did last year, and we're going to throw that one in today. I think the other ones we work with tomorrow. So go ahead and tell me, Willie, what does L'Hopital's rule say you do?
Take the derivative of the top.
Yes.
The derivative of the bottom.
Yes. Take the derivative of the top over the derivative of the bottom. So you just need to know all your derivative rules, which we're really good at derivatives, right, Willie?
Yeah.
So, the proof of that, by the way, you would understand now. You wouldn't have understood it last year, I don't think. But I did put it on the next slide. So some of you I know like the proofs. So let's go use L'Hopital's rule on this one. It would be the limit as x approaches 2 of the derivative of the top. Mason, real hard question. What's the derivative of the top?
6x.
You're so smart. And what's the derivative of the bottom? 1. If you choked on that, you're voted off the island, right? Then what do you do after you take the derivative of the top over the derivative of the bottom? Plug it in again, right? My limit is 5. What does that mean, though? Just to keep it real so that you're not just getting stuff. Katie, when I get a limit of 5, what does that mean? Yes. I don't like the word it, but yes. As you approach, you know I hate the word. As you approach 2 from the left and the right, the y values will be up at 5, right? That's not how we did, like this right now to my AB kids would be great. They'd be going, what are you doing? That's not how you taught us how to do it, right? Because L'Hopital's rule came later. So what else could I have done with that one, Katie? Factored it. So watch. This is how they would approach it. One like this, I'd say go either way. If Thomas uses L'Hopital's rule, Witter, you factor, cancel. One like this, it doesn't matter. They're about the same amount of time. But watch and see if you go back to your AB. What did it mean happened on the graph? Who would I picked on? Catherine, you? Noah. What did it mean happened on the graph when we got the 0 over 0? Way back to last year. What was there on the graph? There's a hole in the graph. Yeah. And x equaling 2 is causing the 0 on the top and the 0 on the bottom. So the hole's at x equals 2. Right, Amy? Because we can't divide by 2. But that helps you factor if you're like, well, there's got to be an x minus 2 on the top. Which would mean this one's a 3x and a 3x what? Minus 1 or plus 1? Minus. Gone, done. Now graphically, back to you, Noah. You said there's a hole in the graph, right? Right? Really, this function is the line y equals 3x minus 1. If you were to go graph this on any graphing calculator, it would look like the line 3x minus 1 with one small difference. So you can remember what it is, because I told you guys need to remember all your AB. Witter, what would be the difference between this original one on a graphing calculator and this one on a graphing calculator?
3x minus 1 doesn't have a hole.
Right. Yes. They're the exact same thing, except this one, it's going to go up and have a hole at 2, 5. Does that make sense? So how else could you have done it like that? Which way should you do it? I don't care for that kind. All right? So that this is not advanced L'Hopital. This is last year. That's why I'm talking super fast. Thomas, I don't always talk super fast. What do I? I do. Sorry. Well, I guess I. Thanks a lot, Catherine. All right. So back up here, you plug it in, and like we said, we got 0 over 0. But by the way, last year's AP test, I was a reader for one where they plugged it in and didn't get 0 over 0. They got a really nice number, but guess what a lot of kids launched into? L'Hopitals. So you got to be careful that you do, Katie. I'm just telling you I don't want to do the arithmetic, but plug it in because it could be nice. Now, with L'Hopital's rule, and again, you're going to start writing equals and you're going to write an LH over it so I know when in the process you launch into L'Hopital's. For these, it's right at the beginning, but tomorrow it goes skyrockets and gets difficult. So we're going to take that same limit as x is approaching -3 from both directions. Derivative of the top. Mason, you were so good at the last one. I'll give you this one. What's the derivative of the top? Oh, so nice. Derivative of the bottom, Katie, you might want to do it off to the side, right? But the 2 is at least going to go to 0. So we bring the 1/2 out front. X squared minus 5 to the -1/2. Awesome. Times the guts, chain rule. So lots of derivatives, integrals mixing in this chapter. Cancel. Cancel. We good? Will, you good? X over, what did you injure, by the way?
My ankle.
Your ankle. Is it better?
Yeah.
Perfect. Good. I was worried about you. You've had a rough fall.
Yeah, I know.
Jeez. Good Lord. Could one more thing happen to you? Let's see. So where was I? Sorry, I lost track. I took my derivative of the bottom, right? So that's really over here. Go ahead and do it. And you guys tell me, you can just reciprocal, plug it in. What do I get? You know I hate arithmetic. What do we get? Katie likes it. She's got -2/3. -2/3. -2/3. Maybe -2/3. All right. Now, I'm not going to go through this one, but again, if I was giving this as a review day for AB, do you guys remember how they would do this one? What did you do when you had those roots? Multiply the top and the bottom, yep, by what? The conjugate. Yeah, and it foils and it kind of gets messy. So L'Hopital's is nice. Let's move on. Now we'll start bumping it up. All right? What's the natural log of 1, Harvey? 0 minus 1 plus 1. Trust me, that's going to 0. This is going to 0. We're going to L'Hopital it. Okay, this one is nothing new yet. Again, I'm just kind of easing up on the new ones. Thomas, do you remember what the derivative of the natural log of x is? 1 over x, yep. Or 1 over u prime is 1, and that'd be -1. On the bottom, 4x cubed minus 1. Now, when I go put the 1 in, I still have a 0 on the top, but I have a constant on the bottom. So what's my limit? 0. Now, somebody tell me why, if this was multiple choice, you should have known to circle 0. Daniel, I haven't picked on you for a long time, but going way back to last year, would your gut have told you that that limit is 0?
I don't remember.
Well, the good.
Probably.
Because then otherwise, if everyone remembered everything from last year, I'd be wasting your entire day instead of just most of it, right, Bonnie? Have you known most of this? It's getting new. Tomorrow's all new. But I don't want to launch you to the really new hard stuff. But last year we talked about how if it's multiple choice, maybe you just know that one. Do you guys remember? Maya, do you remember? We talked about how powerful functions are. And we talked about how the weakest function in the world is a constant. Y equals 3 gets killed by everything because it's not growing. right? Its derivative is 0. The next weakest is the natural log function. It grows super slowly over time, or as x gets bigger, right? So really, this has a much more powerful function on the bottom than on the top. Now you're nodding, right? So probably going to get beat out. Now let's go to the next one. And again, just trust me, Catherine. When you put in a 0, you get a 0 out. Okay, on both, top and the bottom. So let's launch into, and you're going to start telling me by L'Hopital's rule starting tomorrow, so I'm going to start it early. We're going to still be taking the limit. Don't drop your limits early, you know that's a pet peeve as well, right? And go ahead, Annie, derivative of e to the x.
E to the x.
E to the x, derivative of x,
1.
derivative of 1.
Oh, 0.
0, thank you. Okay, on the bottom, we'd have e to the negative u times a negative 1, and it's going to cancel out. All right, so now, when I go put the 0 in, right, what do I get? 2. Nice and easy. What does that mean when I graph this? I have no clue what this looks like. It's not a parent function. I have no clue. But I know as I approach 0 from both directions, I'll be at 2 on the y-axis, and there'll be a hole there. So another review. How do you know when there's an asymptote versus a hole in the graph? Let's go with Daniel, because your last answer was, I don't know.
Holes are removable.
Yes? What is it about what originally happened that made me know there was a hole before it? He said holes are removable. That's totally true, right? All I'd have to do is say f of 0, you're 2, and it'd plug up the hole. But how do I know if there's an asymptote there instead of a hole? Way back to AB, that's why I'm doing this, just trying to bring that. This is what we got originally. Who remembers what happens when there's an asymptote instead of a hole in the graph?
It doesn't equal 0.
Yes. The top is a number, like 5 over 0. And kind of think about that. If I said to Thomas, Thomas, how many 5s fit into 0? 0 fit into 5, you're going 0 plus 0 plus 0 plus 0 plus 0 plus an infinite amount, right? So we're going to infinity. Think of that. No, you're not. That's a good way to remember it, Bodie. Now, I'll start slowing up a little bit. That was level 1 and 2. We're going to move into level 3, and then 4, and then levels 5 through 8 are tomorrow. All right, it gets really difficult tomorrow. So Harvey, are you ready? Plug in 0 on the top, what do you get? And on the bottom, what do you get? 0. All right, so maybe Yoder's like, why are you putting those arrows and not equals? What did I tell you about last year? We're putting equals 0 over 0. Here's what happens. Suppose, let's just say Thomas for shits and giggles, right? Because you weren't with us last year. We said you can't write this because if you go like this and this and this and this, and our answer ends up being a half, like on the last one it was 2. What did I say College Board dings you for? Language. Exactly. They say, well, he's saying 0 over 0 is a half. That can't be, right? So don't ever write equals 0 over 0. All right, put those little arrows or rewrite it or something, but don't put that because you get the answer point taken off. So now this is a candidate for L'Hopital's rule. We're going to get to one pretty soon that's not, and we're going to have to play with it. Maya, you bored? Kind of, right? It's like, I know all this, but there's some little things that we don't know. All right, how about, Catherine, back to you. What rule am I going to launch into? Product. Let's go do it quickly. First, D second, plus second, D first. Derivative of cosine, Willie?
Negative sign.
Perfect. Derivative of a constant,
0.
y? Y has no slope, sure. Y equals 1's got 0 slope, and that's what derivatives are. Perfect. On the bottom, 1. So now on the top, what's cosine 0? We should be good with our unit circle, right? What's cosine of 0? 1, right? What sign of 0? What sign of 0? 0. Yeah, so the whole top's a 0 and the bottom's 1. So what's your answer? Go ahead, Kate. 0, right? All that, and it's just 0. Now, actually that wasn't up a level, now it is. So now I'll slow down. Here we go. 4 to the 0 is 1. Sine 0 is 0, minus 1, top 0. Right? Tangent of 0. Sine 0 over cosine 0 is 0. So it's all going to 0. Annie but Annie, don't write equals 0 over 0. You want to show your AP reader that you know that's going 0, 0, you do that. If it's an FRQ, remember last year, but we'll work on that later. All right, so I'm going to launch into L'Hopital's rule. This is what I'm a little bit afraid of. Do you guys remember what the derivative of 4 to the 2x is? I'm a little afraid we forgot that. And some of you are going like this. This is great. That's the only reason I'm doing today is for the every once in a while a couple of you are going, I need a little bit on that. Okay? It's not due yet though. Who does remember what it is? This is great. Kinda? What do you think? If you get it wrong, we'll just publicly wrong with you.
2 natural log of 4.
So close. But that's just a constant. You're missing some stuff. But it's good. I'm going to change it. Oh, you know?
2 natural log 4 times 4 to the 2x.
Yes. How do you remember that?
Because e to the x derivative is natural log e, which is 1.
Ah, she's remembering my little trick last year where I said people always forget when the base isn't e. When the base is e, you always remember. What's the derivative of e to the 2x? And you'd say, oh, it's just e to the 2x times what? 2. But actually, if I proved it and did it, which I'm going to, because none of you remembered, which means I must not have showed the proof last year. In case I know you didn't. Because you guys remember when I show the proof. So I'm going to pause and we'll do the proof. But really in the proof, there's an ln e in front of it. What's the natural log of e? What's the natural log of e? 1, right? So this is what Witter was saying. She goes, well, I remembered, if you didn't hear, she said 4 to the 2x. She's thinking e to the u. She's thinking du, but it also has an ln 4 in it, whereas that one had an ln e. Now watch, we're going to prove it though. You ready? Ready for a proof, Will? Here it goes. Let's prove what the derivative of y equals, let's just say a to the, do I want to do b? Let's just do 2x in that specific case just so you can see it. All right. Whenever you have the variable in an exponent, remember from last year, I'd say start off by natural logging. Who remembers why, Yoder, do I start by natural logging? Yes, I can bring the power out front from my pre-calc days. So I'd have the natural log of y equals 2x ln any base, right? And that could have been a kx or a bx, or I'm just doing it for this specific. Right here, I don't know the derivative, so I'm doing something I do. What is the derivative, Maya, of the natural log of y? What'd you say?
1 over y.
Yes, 1 over y, and 1 over u times its derivative. We did that one a lot last year. Remember, we always just went y prime over y, so it's the same. All right, over here, the natural log's a constant and 2's the constant. And the derivative of any constant x is just the constant, right? So it's like if this was, what's the derivative of 8x? And you'd say 8. Well, what's the derivative of this? 2 ln 8. So notice we've got the 2 ln 4, right? And then we have to multiply by the y, which was a to the 2x, or in our case, 4 to the 2x. So watch this. What is the derivative of 5 to the 8x? Pretend it's e to the 8x. You don't want to prove it every time, right? So Harvey, what's the derivative of 5 to the 8x? Pretend it's e. Yes? 8 ln. Let's pretend it's e. Are you ready? If it's e to the 8x, it'd be e to the 8x times 8. It still is. But there's an ln what? 8. Yeah, it's not ln e. So let's go back up there and wrap this one up. Will that pop up on the AP exam? Probably not. I saw them once have a 2 to the x, but usually not a whole lot. So we're still taking a limit as x approaches 0. There's my derivative. Derivative of sine is cosine. 1 goes to 0. Who remembers the derivative of tangent? Secant squared. Thank you, dear. And the derivative of sine? Cosine. Okay? I'm not going to wrap that one up now. It's just plug and chug. I wanted to hit that one for this. So one last time. Let's see if you can all write this down. What is the derivative of not e, but 7 to the 3x? Pretend it's e. Because that does pop up on your worksheet today. I don't remember what one it is, but there you go. Pretend it's e. So 7 to the 3x times what? 3 with a ln 7. Perfect. And remember that 3 ln 7 is just a number. Okay, it's some constant. Excellent. All right. I'm going to skip over that and head right down to these. All right, here. We'll skip over that top part. It's not particularly important. Who knows the answer to this one right now? When we approach e, your hands are up. We're approaching infinity, right? That's all about where the power is. Infinity is super powerful. As we go there, things get powerful. And it's about who's more powerful. So what's the answer to this one right here? Go ahead and blurt. 2/3, right? That doesn't need L'Hopital's. But suppose Catherine's just like in love with him, right? He's actually pretty cute. He's got this hair. There's a picture of him on the slide. He's like got this long face and his hair is like this. That's what L'Hopital looks like. Except he does have features. All right. So if I did L'Hopital, watch me do it really fast with poor notation. 6x squared minus 8x minus 5 over 9x squared. Shoot! Right? It's still infinity over infinity. 12x minus 8 over 18x. Shoot! It's still infinity over infinity. 12 over 18. Guess what that reduces to? 2/3. Don't do this. Right? On that kind. So the next page, I'm going to come back to this one. What's this? Is it the exact same one? No. Is it? It's still 2/3. All right. Let's talk about when that doesn't work. So down on the bottom, this guy. Be very, very, very careful. Okay? What is the square root? Because I have to see where there's more power, on the top or the bottom. What's the square root of x squared? Thank you, plus or minus x. Yeah, it's actually the absolute value of x. If you were to graph this on your graphing calculator, you can go try it sometime, but if you graph y equals the square root of x squared, it's going to look like that. It's the absolute value of x. So this is really the limit as x is approaching infinity of the absolute value of x over x, because 1 does nothing. $2 trillion and $1 in national debt is really no different than $2 trillion and $2, right? The 1's not controlling anything. As we approach infinity, though, this would be positive, and so would the bottom, and they'd be the same number. So what's this going to approach? Positive 1, right? Now watch a little change. Are you ready? Boom. Now what's the answer? -1. Yeah, because the top would always be positive and the bottom would be negative of the same stuff. Does that make sense, Daniel? So you have to be a little bit careful. And last one, before we hit the new stuff. This is of the indeterminate form infinity over infinity. The top is going to infinity. It's actually a parabola, right? It's going like this to infinity, the end behavior. The bottom is also going to infinity. So what rule would you launch into? Go ahead. Little L-hops, yeah.
That's what I previewed to.
L-hops will hop into L'Hopital's rule. However, if it's multiple choice, what do you think you would circle to save yourself some time? 0. Why? Yeah, the exponential functions in the denominator, Catherine, that kills these. And picture taking the derivative of the top. 8x minus 5. 8, 0. Picture taking derivatives on the bottom. E to the 5x. 5e to the 5x. 25e. Do you see how the bottom's growing like crazy when you L'Hopital it and the numerator's approaching 0? So if this was multiple choice, Thomas, go the bottom's killing it. If it's not, what do you have to do? If you put 0 and it's not multiple choice, how many points will you get for that question? 0, exactly, even if the answer's right. So then you would have to say, well, the top is going to 0, the bottom's going to 0. I'm going to L'Hopital it, and you'd have to go through it. But normally, that's a multiple choice question. So now it's new. All right, so we got a couple new ones here. First of all, I'm approaching 0 from the right. It says, why do you think we're approaching from the right? Think of a natural log graph. Do you know what it looks like, Annie? The natural log of x? It looks like this. So why do you think it has to say we're approaching 0 only from the right? What do you think, Bojan? That's not the graph of x, ln x. That's just the graph of ln x, but there's no approach from the other direction. There's no graph over there. So that sometimes kids will say, well, why is there a little right in there? Why does it matter? Because you have to stay in the domain. So stay in the domain of natural log. So I said you always do direct substitution first. Look what you get. You'd get a 0 times. And as we approach 0 from the right, what does natural log approach, Katie? In asymptote. In particular, it's going down. So what do you think I'm going to write? Negative infinity. Perfect. This is not 0. Isn't that weird? This is one of the other indeterminate forms from page 1. If you want to page back and look at them, I'll write them up on the top, like for you for the test. So you're not like, I'm not sure if I got one or not. They don't need to be memorized. But when you get one like this, you can't just say it's 0. What do you think most kids circle? 0. All right? You can't do that because this is unknown. Kind of weird. Did you know 1 to the infinity is indeterminate? What do you think most people think it is? If I had a gun to your head, I said, what's 1 to the infinite power? She would say an indeterminate form. What would she say? 1. My gut tells me it's 1. It's not. So isn't that weird? We'll talk about that more later, but yeah, it's very strange. So L'Hopital's rule won't work. It only works on quotients. So let's write it down again. It was the limit as x approaches 0 from the right of x, ln x. And it can only work when you get this or this. So I have to think of a way to rewrite this as a quotient. And this is new. So now if you tune me out because you're like, oh, this is all last year's. Now it's new. Okay? So the first thing I'm going to do is say, well, it gave me an indeterminate form that's not one of the ones I can use L'Hopital's on. So you get a little clever and you go like that. Is that the same thing? Danny, do you agree? That ln x over 1 over x is exactly the same thing? Now, when you get here, you always have to say what indeterminate form you're getting. So be very careful. As I approach 0 from the right, natural log is going to negative infinity. What does 1 over x go to as you approach 0 from the right? Like 1 over 0.000000001. What is that going towards? Or you could think of the graph of it. Cody, do you remember what the graph of 1 over x looks like? It looks like this and that. Pre-calc. So as I approach 0 from the right, what's 1 over x approaching? Go ahead, tell me. Can't hear it. You guys are quiet today. You're not normally this quiet. What does 1 over x approach? Go ahead. Infinity. Yeah. Infinity over infinity is L'Hopital worthy. So did you see how just a little rewrite and I got it? Right? So you would just go up here and say, well, what's the derivative of the top? And this is where you'll tell me you're launching into L'Hopital's rule. You're telling the reader or your grader that you just hit an indeterminate form that's worthy. These are the only two, right? The infinities over infinity are 0 over 0. Derivative of natural log is 1 over x. Don't forget, I just dropped my limit. Pet peeved myself. And what's the derivative of x to the negative first in the denominator? It'd be a negative 1 over x squared, right, guys? Mason, you have any questions, or are you good so far? And then I'd multiply by a reciprocal. This actually cancels to equal negative x. And when I plug in a 0, it's just going to 0, which most people would guess. That's why, Maya, if it's not multiple choice, that's why you don't get any points for that. Do you see the method behind the, it's not 0 because 0 times negative infinity is 0. We'll get different answers with that one coming up. These are long notes, longer than normal. This one's really similar, so I'm not going to do that one. I have 2, I think more. Here we go. Are you ready? First one, I get infinity when I plug it in for direct substitution. And then I get sine of 1 over infinity. Witter, what's 1 over infinity? What's 1 over infinity? 0. And what's sine of 0? 0. This is, again, another indeterminate form. I'm going to rewrite it. Anticipate how I'm going to rewrite it. What do you think I'm going to have on the top? What do you think? Yeah. Which one's easier to flip? Yeah. So I'll have that one on the bottom. So I'm going to have sine of 1 over x all over 1 over x. Tom, do you agree with me that I haven't really messed with the problem? I've just changed it. So now instead of infinity times 0, I have 0 over 1 over infinity. And infinity is weird, Ryan, but what is 1 over infinity? 0. So now, notice I'm not writing equals 0 over 0. So now I'm going to write this equals based on L'Hopital's rule. Are you ready? Who haven't I picked on for a while? Noah, what's the derivative of sine? Cosine. Leave the guts intact. Just drop my limit, which I hate. All right, Noah, what's the derivative of the guts? Or x to the negative first? Yeah, negative 1 over x squared. Excellent. So there's the derivative of the top over the derivative of the bottom, which is also negative 1 over x squared. You good, Bodhi? You guys are super focused. I see it in your eyes. It's the minute it went new, you guys were like laser beams. It's weird. The new stuff. All right, now watch what happens. Boom, boom. You good? Technically, the answer to this is cosine 1 over infinity. You're nodding, Katie, right? And what's 1? It's actually 1 over x as x goes to infinity. Infinity is not a number, but we're good with it, right? So I'm actually taking the cosine of what, Kate? Cosine of 0, which is not 0. It's, do you see how that same indeterminate form of 0 times an infinity? On the last question, we got 0, which is what most people would guess. And on this one, you guys are nodding, we got a 1. So do you see how it's indeterminate? It lends itself to being different. So that's one method, is to strategically write those, and that's when you get the infinity times the zeros. That was the last two. You just rewrite it like we did on the last one. Watch this one. This is infinity and this is infinity. What if Mason didn't know that? Here's how you'd figure it out, right? Like Mason, did you know secant of x as x approaches pi over 2 is infinity? Here's how you think of it. Are you ready? Thomas, what is secant? 1 over what? Cosine. Okay? And Mason, it'd be 1 over cosine pi halves under x substitution, right? Mason, what's cosine of pi over 2?
0.
Yes. And how many zeros fit into 1? Do you see how you can walk yourself to it if you're not quite sure? So watch the next one. This is really sine over cosine. It's sine pi, it's still 0 over 1. So some people, like Katie, some people know that the graph of tangent has the asymptotes at pi over 2. So if they remember the graph of it, it just depends. But you do need to recognize that it's infinity minus infinity. Thomas, what do you think most people out in the hallway, if I said what's infinity minus infinity, what do you think they tell me? 0. It's not, because infinity is a destination, not a number. And it depends, you might be way farther along towards infinity than he is. So your infinity minus his is a quite large number. Isn't that weird? So you gotta be careful, we're nodding. They're thinking, oh, this is 0. 9 out of 10 calculus students across the world will circle what for that? 0, because it looks good. But watch what it ends up being, all right? Think of how we could maybe get this, because again, we can't L'Hopital, and it's our only method. We can't L'Hopital until we get 0 over 0 or infinity over infinity. How do you think I'm going to tackle getting this trig expression as a single fraction? Allow you to blurt. What'd you say? I am going to subtract them. There. Exactly. Get a common denominator. Right here it says get an LCD. So when you get the infinity minus, by the way, what do you think this is though? That is not one of our indeterminate forms. What's infinity plus infinity? Yes, thank you. What do you think that's going to? I thought you were going to say, I was plugging my ears. I thought you were going to say 2 infinity. Like x plus x is twice x. But what's twice infinity? Infinity. All right. So here we go. We're going to take the limit of 1 over cosine x minus sine x over cosine x. You need to know your trick. Thank you, Kate. Harvey, I haven't talked to you for a while. Are you ready again? Boom, boom. Am I writing too fast, Whit? No? All right. So Harvey, on the top, what would I have? Yeah, let's just do crisscross. Actually, I don't need to because I have a common denominator. Let's just 1 minus sine x over cosine x. It's easier. All right. So now take a look. When I replug it in, I get 0, right, over 0. Now what? Okay, I want you to know. Now I can do L'Hopital's rule. Yep, make sure you go like this so we know, I know, there's always one point for knowing which indeterminate form you've got. It was originally infinity minus infinity. We transformed it with Katie's common denominator to be 0 over 0. Now you're launching into L'Hopital's rule, which you know how to do, so I'm not going to wrap that one up because we're good at it. I want you to be able to start the assignment. All right, next Next one, are you ready? Last one. When I put in a 0, I get 1 over 0 minus 1 over 0. Really, what is that? Go ahead and tell me. Bodie, I haven't talked to you for a while. Really, what is 1 over 0? Infinity minus infinity. The answer to this is not 0. I actually think it ends up being like a fraction of some sort. So you can see why they don't give any points for somebody going like this, even if that's the correct answer, because a lot of times it's not. So how do you think I'm going to rewrite this so that I can get my indeterminate form? How am I going to rewrite it? Go ahead, Maya. I haven't called on you for a while. Yeah, and when the common denominator is 1 times the other, right? It's just easier to go x minus e to the x minus 1 over x times e to the x minus 1. Criss-cross, multiply across. It's the easiest way. Watch what happens when you put the 0 in, though. Now what do I get? I don't get infinity minus infinity, right? You're nodding, right? What am I getting this time, Noah? 0 over 0. So what are you going to write right here? Equals. But what are you going to put above the equals for me? Go ahead, Noah, I'll stick with you. LH. And then it passes off to Calc 1. Do you need me to finish that one, Thomas? So it's going to be the derivative of the top over the derivative of the bottom. Bodie, how would you take the derivative of the bottom? Product rule, right? I want you to have time to work a little bit. So I'm going to go dot, dot, dot. But I'm going to tell you, your next one, you get 0 over 0 as well on the replug. So once he does 1 minus e to the x for the top and the product rule on the bottom, you're going to get 0 over 0 again. So then what? L'Hopital again. Yeah, and then it'll work, just so you know. So I do want to give you a chance to get started, and I want to do some specific. This isn't due today. It gets finished tomorrow. So today, I'd say get as far as you can, and then maybe do what's a fair amount of homework. I don't know. Let's eventually do it. Here's all we do with this stupid thing. Oh, you tell me. All right. I don't want to start with the easy ones. I want to go to find. They're going to go pretty quick on the first page because they're nice. I want to find one of the new weird ones. Actually, you're going to cruise. What's the answer to number 15? Everybody go. Flip to 15. I'm going to count to 3. You're going to blurt the answer. Number 15. 1, 2, 3. Done. You don't need L'Hopital, right? Same with 16. That's just, some of these are super fast. You'd be like, oh, this is forever. It's actually not. Okay. Number 16. 1, 2, 3. 0. Excellent. Okay. Are we done already? I talked a lot. I'm sorry. I'll extend, this isn't due today. And tomorrow, if it goes long, I'll just extend it. I don't like you to have more than a half an hour outside of class. But do some of it, okay? Yes, my dear. Uh-huh. That's the 10 to the 2x times 2 natural logarithm. No, they're tied. Yeah. Good question. Just a second. Annie, how you doing?
Good.
That's a lot of notes. I've been doing that for a long time. Yes. Thank you. Thomas, how'd it go? What? You getting it? Okay. For which kind now? Repeat it one more time. You ready? Bryce, how are you doing? Okay.
Tired.
I'm tired. Why?
Kind of staying on.
Why?
Trying to figure out this homework
work. You're getting caught up. 5 parts. That was fun, right? Can you prop that open for me?
So
Yeah.
this one.
Yes.
He kept saying plug 0
Uh-huh.
and
Because of the graph of natural log, it's a parent function that they had to memorize. And it goes like this.
Yeah.
So as you approach 0 from the right on the natural log function, the y values go to negative infinity.
So if you plug 0
You can't.
You wouldn't
There's
be able
no
to plug zero.
ln0 on a calculator is going to say error. Because it's saying e to what power is 0. And you can't raise e to a power and get 0 out. So you can't actually plug the 0 in. It's where it's going as you head towards it. That's a really good question.
0.
How are we doing?
What's the point of putting 0 to a power? It's just automatically 0.
It said 0 to the 0.
That's one.
That's an indeterminate form. That's what we just talked about today. That's tomorrow's Thomas. What happens when you get 0 to the 0? He just said it's 1. I'm like, no, it's not. Indeterminate form.
There's two problems.
Bye, kiddo. Yeah.
0 to 0 is just a problem. 0 to
How are we doing, 40? Good.
still a problem.
How are we doing, Marcy?
Good.
You didn't keep up, man.
I
Catch up with you.
Let's just go generically.
Yeah,
And say 0 is a problem.
no,
Zero
zero
is
is
the-
zero is the solution.
No, 0 is the problem.
I went to click on the Delphi map. I accidentally did the wrong one.
You did
So-
the wrong indication. Wrong.
Like you did it last night. She posted the one for today.
Oh.
So there was 2 in there.
All right.
So I was